Number bases are a little difficult to understand at first, but learning about them helps us understand how our regular base, base 10, works, and that can make computation a little bit easier when you understand that. So let's take a look at base 10. I like to explain this the way I learned it when I was a kid. What we used to do, and I think they still do this, is they would make a place value chart. And I'm not going to make this one so big as it looks like right now. So we would start with the ones place, and then you had the tens place, and then the hundreds, and then the thousands, and so on and so forth. So where did these numbers come from? Why is the next place after the ones place the tens place? So where this comes from is we say that 10 is our base. So we're working off of powers of 10, really. And 10 to the 0 power, if you remember from an earlier math class, 10 to the 0 power is equal to 1. 10 to the 1 power is equal to 10. And 10 to the second power is equal to 100. And you can keep going. 10 to the third power is 1,000, and so on and so forth. And you could just keep going forever. So that's what we've got, and just on and on. So when we look at a number written in base 10, for example, what if I had 5 in the thousands place, a 2 in the hundreds place, 0 in the tens place, and 4 in the ones place? What does this really mean? It means 5 times 1,000, or 5 groups of 1,000, plus 2 groups of 100, so that's 2 times 100, and I'm going to wrap around here, plus 0 groups of 10, so that's 0 times 10, and I could really skip that because that's just 0 anyway, plus 4 times 1. And when I add that all together, multiply and add, then I get 5,204. So of course you can read that right out of that place value chart, and that's very straightforward. So that's what you're already familiar with. So now let's see how that relates to other bases. And first we'll look at a base that's less than 10, and then we'll look at bases greater than 10 because they're a little bit different from each other. They all basically work the same way, but there is some slight difference there. So let's take a look at base 7 because this is what you asked about in your email in particular. And I'm not going to do a computation just yet. We're just going to talk about how does base 7 work. So similar to when we were talking about how do you get the place values in base 10, I can do the same thing for base 7. I start with 0 exponent, and anything to the 0 power is 1. So when you make a place value chart, and that's what I like to do in these cases, I make these columns bigger so it's easier to write in. So 7 to the 0 power is equal to 1. 1 is always your first place value on the right hand side. And then we have 7 to the 1 power. Well, that's equal to 7. So I'll put that here. So what looks like the tens place, that's really just your base. Whatever number is in this place value, and I should say whatever number is the place value, right? It's not that you have 7 in the tens place, it's the sevens place in this case. So that's your base always. And this is always 1 for the first place value. So you always have 1 and then whatever your base is. But now we're going to do what is the base squared, and that is 49 in this case. So the next place value is the 49's place. And then you could continue, and we're going to stop with 7 to the 3 power because I don't know 7 to the 4 power off the top of my head. So I'd have to get my calculator out. So we're just going to go with 343, which is correct. Okay, good. All right. So now I have a place value chart. So suppose now that I wanted to work with a number that is in base 7. So I want to work with the number 2 4, 5, 3. Now notice I stopped for a second there. I was trying to be really careful. I need to be careful that I only use digits that are less than whatever the base is. I can't go over the base in terms of what digits we use. So when we're working in base 7, then our digits are always 0 through 6. 0, 1, 2, 3, 4, 5, 6. So those are the only digits that I can use in base 7. If I want to know what this base 7 number is in base 10, I can write this in base 7, of course, outside of that place value chart, just by writing 2, 4, 5, 3, and then I put a little base of 7. I like to write out the word just because, especially when I'm handwriting something, it can be a little ambiguous. Am I just like not making my 7 very well, or is it really supposed to be the base? So I like to write out the word, but normal notation is to actually put a 7 there, so it should look really like this, and you can really go either way. So whatever you prefer. On the test, you'll see it like this, and in the homework the same. So I'm not going to change that up at all. All right, so we want to know what this is equal to. Well, now that I've made my place value chart, then I can say, well, that's 2 groups of 343. So the headings of my place value chart I made in base 10 because that's what we're familiar with. So that's how your calculator works, which is really the important part. So those headings are in base 10, even though the number inside the chart is in base 7. So we're going to start with 2 times 343, and then we'll add to that 4 times 49 plus 5 times 7, and then finally plus 3 times 1, and I always just write 3 because you don't have to write the times 1, it's just 3. Okay, so I'm going to pause this for just a sec while I find out what that is equal to. Okay, so I just put that into my calculator and I got the number 920. So 920 is my number in base 10. I don't have to write the little 10 there. I could write 920 and then a little 10, or 920 and then a little 10 like that. But you can see where it's a little difficult when I'm writing the 10 as with the digits rather than as a word. That can be a little confusing. But I don't need to do either of those. I can just go with 920. If there's no base there, we just assume that it's base 10. All right, so that is a base smaller than 10, and I'm going to stop this video here, and then I'll make a second part where we do a base greater than 10, and then we'll do a computation.